Our planet, the Earth, is not always welcoming. Cold, drought, earthquakes, volcanoes, altitude. The extreme conditions of many sites make them virtually uninhabitable. Yet humans have managed to settle, like here in Chile. Today, modern science and technology can help us face the forces of nature and even turn them to our advantage. The Chilean people are faced in the north with the most arid desert in the world, and 3,500 kilometers further south in Patagonia by almost constant rain.
The river suddenly flooded and killed my horses, cows and sheep.
I have 2 hours of irrigation every 24 days.
This system allows life.
Here, in this place, we are taking off. We are going to the sky.
Chile is still a land of pioneers with vast open spaces where humans must exist alongside unspoilt nature. How did Chileans adapt to the forces of nature shaking their country? And what revolutionary technology did they develop to take advantage of the resources of this inhospitable land? Today in Chile, it's possible to observe the incredible ability of human beings to adapt to hostile environments through science. A thin ribbon of land from Peru to Cape Horn, Chile offers its inhabitants a great variety of ecosystems and climates. The aridity of the north and the humidity of the south have the same cause: the Andes, a 4,500-kilometer mountain range stretching the length of the country. In the north, Iquique is the largest coastal city in the Atacama Desert. It presents a surprising geological peculiarity that allows you to grasp the natural forces at work all along the Chilean coast, an immense dune at the heart of the town. The Chilean coast allows paraglide pilots to record flights of more than 400 kilometers. They take advantage of the long Chilean coastal range, seeking out ascending thermals produced by hot air from the Atacama Desert, meeting cold air from the ocean.
It's like a block everything with the wind and humidity. So the humidity stopped here, and after all this hill, it's very, but very, very dry, the desert.
The Atacama Desert receives no moisture because it is stuck between two parallel walls, the coastal range to the west and the Andes to the east. The existence of these two parallel ranges is explained by the formation of South America. The Earth's crust cracked, forming the South American continental plate and the oceanic plate. Some 90 million years ago, these two tectonic plates collided, and the heavier oceanic one passed underneath the continental shelf. The Andes sprang up vertically from the edge of the oceanic plate, 200 kilometers from the coast. At the summit, almost 7,000 meters high, the Atacama Desert is cut off from clouds laden with moisture from Argentina. But this extreme land, the most arid in the world, is still a home for some people. The aridity here allows for the existence of an astonishing diversity of geological structures. Elsewhere, rains erode and level the landscape, but here the wind and the salt can express themselves by carving the landscape over centuries, recreating natural artworks. Rainfall here is the lowest in the world. It rains 0.5 millimeters per year. 1 square meter receives half a liter of water annually, 1,000th of the average rainfall in France. In the absence of rain, features remain largely unchanged, like this geoglyph, the Atacama Giant. The stones that make it up are simply laid on the ground. They haven't moved for over 1,000 years. They continue to draw a strange silhouette that served as an astronomical calendar to predict lunar and seasonal cycles for agriculture. But the extreme aridity of the Atacama Desert has a positive aspect for scientists. There are very few water droplets suspended in the dry air. Humidity is under 10%. Visibility is therefore excellent. On the high plateau, at 5,000 meters altitude, conditions are perfect for astronomical observation. That's why ALMA, the world's largest radio telescope, was built here. ALMA, co-financed by the European Space Agency and NASA, has enabled many discoveries about the origins of the universe through observations of distant stars. It's a high-precision instrument 10 times more powerful than orbital telescopes like Hubble, thanks to its unique geographical situation. To reach the network of antennas at 5,200 meters altitude, visitors must first take a medical. Doctors provide a bottle of oxygen to prevent the risk of pulmonary edema and respiratory discomfort. Thais Mandiola is in charge of accompanying visitors on the only road that gives access to the plateau. This is the route the ALMA antennas take, each of them the size of an 8-story building.
It takes about 5 to 7 hours because the transporter moves about 7 to 10 kilometers per hour, very slowly.
One of the 66 antennas is being moved to adapt the telescope's configuration to the observations the astronomers want to make. The road climbs to the foothills of the high volcanoes that surround the Atacama Basin.
That's the Lascar volcano. That's the most active volcano here in the north of Chile. We do have everyday earthquakes around here because of the volcanoes. It's not very high level.
Atento, guardia control, móvil 27, naces, kilómetro 21, sin novedad. Well, this is just for safety precaution. We've had accidents here because of the altitude. You get altitude sickness, so this is a way that they monitor that all the workers that are using these roads are well.
At the end of the road is the plateau where the network of dishes is deployed.
These ones are the Europeans. You see the straight structure above the dish? That's the design that the Europeans have. The North Americans are this one in front of us. You see that arc above the dish? It ends in the edges.
An antenna is being prepared for relocation. To allow for an observation that astronomers want to make, some or all of the 66 antennas will be moved. It is a long and difficult job for the engineers when the oxygen content in the air is half that at sea level. Technicians must have special equipment to work at this altitude.
It's necessary just for safety precautions and because of the low oxygen that you have here. So they have this way the ability to concentrate better, just to work better, being all the time connected to the oxygen tank. And they are more adapted now to work at these very extreme conditions, up to 8 hours a day. We can see how the power of working together, many people, many countries, what can accomplish. This is an example of what is possible for humanity too, of being able to build this at this very harsh environment.
The engineers oversee antenna reconfiguration from a pressurized building. Chilean astronomer Juan Rodrigo Cortés has worked here since 2005 and the beginnings of Project ALMA.
The main difference of ALMA with respect to another radio telescope is not only one telescope, it's 66 telescopes. They are joined together. That's what we call an interferometer. So they make like they are a big telescope of 15 kilometers of diameter. Creating all this machinery, put it at 5,000 meters, has been a boost for technology. We need new technology for building all of this. This is, for example, are very precise antennas. You need to be more precise than a fifth of the size of your hair for having the precision required in the dish of antenna.
Even though ALMA is composed of 100-ton antennas, at 5,200 meters altitude, it's a very flexible instrument. Its modular design makes it reconfigurable. Depending on their position, the antennas will allow for observation of either a small zone of the sky with precision or a very extensive area with less detail. ALMA is a unique observatory. Thanks to the special conditions of the Atacama Desert, it has allowed scientists to make many discoveries about our origins.
We didn't know, for example, before ALMA, there were a lot of organic molecules around the stars. So now we know the building blocks of life that are elsewhere in the universe, everywhere. So that's taken one step further to understand why we are here. So that is revealing us an entire universe that we cannot see and we didn't see before. So this pushing the borders of science, at the border of the knowledge of mankind, further, more than any telescope in the world. The deep blue of the sky that makes you feel that you are closer to outer space, and actually you are. For the local people, the Atacameño people, they call it, this area, Chajnantor, that means, place of when you take off. And they were right. Here, in this place, we are taking off. We are going to the sky by looking at it. So there is, kind of a mixture and a link between what Asian people, local people believes, and that we actually were doing.
ALMA, an acronym for Atacama Large Millimeter Array, also means soul in Spanish, the high-tech soul of the Atacama Desert. In the extreme conditions of this desert, mankind has always had to fight to gain a foothold and to put its resources to good use. For almost 2,000 years, the Atacama Desert has attracted humans because of its exceptional mineral wealth. First copper and now rare earth elements used in our advanced technologies. These minerals are present because volcanism pushed them up from the depths of the earth. The entire Andes mountain range is formed by uplift at the edge of the oceanic plate. This is what we call a subduction zone, characterized by many active volcanoes and geothermal activity. Ramon Morales Balcazar, a Chilean ecological engineer, knows this amazing environment well.
We're at the Tatio Giza, at an altitude of 4,300 meters. We're in an area of geothermal activity. It's a place that is sacred to the Licanantai community and which has been used for healing. Morning is the time when the water, in its solid state, ice, begins to melt. So this change in temperature causes the water to slip through the cracks in the ground and touch the hot rock. That makes it boil and creates pressure. It's steam, water vapor, that tries to go upwards to find an exit.
The warm waters of the geothermal springs and the runoff of glacial meltwater deposit the minerals 2,000 meters lower down at the heart of the Atacama Basin. This is a huge bowl containing a salar, or salt flat, a characteristic formation of the high deserts in South America.
This salar formed around 400,000 years ago from glaciers melting in the Andes. This water came down in the form of rivers and underground streams. It has accumulated here with all the minerals the water has collected. The water has gone through evaporation, leaving the minerals brought here by the water, including salt.
A salar is a natural drainage basin. The minerals brought here under the surface by runoff are concentrated for millennia. In the modern era, many potash mines gave rise to mining towns which are now abandoned. Today, the Atacama Desert provides an element essential to our modern technologies. It boasts the largest lithium deposit in the world. Many modern electronic devices contain batteries that use lithium extracted from the Salar de Atacama.
These minerals have accumulated here, and life has adapted to their presence. So the plants and animals that live in the salar have adapted to very particular conditions.
Here, life must fight for its existence against the extreme conditions. At the lowest point of the salar, brackish water rises from the subsoil and lagoons form. This is where animal life gathers. Despite the high salinity, a fragile ecosystem exists, from bacteria to mammals like the vicuna, a cousin of the llama. Conditions, however, are too harsh for human beings. For 9,000 years, people have lived at the foot of the mountains to take advantage of meltwater from glaciers in the Andes. On the edge of Salar de Atacama, San Pedro nestles in an oasis, irrigated by a freshwater river. For the many inhabitants, the sharing and management of this precious resource is difficult, at the heart of the world's driest desert. Turning on a tap at home has certain consequences. Everyone must learn to optimize resources. The running water used by the inhabitants of Atacama is drawn from the water table, 150 meters under the salar. Loaded with minerals, including arsenic, it must be purified by reverse osmosis. The liquid moves through a membrane that only lets water molecules pass. This process is effective, but it consumes lots of energy, and the expensive membranes must be regularly changed. So drinking water in Atacama costs 3 times as much as in the rest of Chile. One part of San Pedro is still not linked to the drinking water network, and the inhabitants have to be supplied by tanker truck deliveries. Water for agricultural irrigation comes from the river. It is distributed to inhabitants through a network of centuries-old canals. Karen Luza runs one of the associations that manages the distribution of water at the heart of the desert. The irrigation canal for her fields begins at her home.
This is my irrigation canal. So what I have to do is shut this down to stop my neighbors and send the water to my land. I have 2 hours of watering every 24 days. Our corn that waits so long for irrigation must be very strong. It's hard to wait 24 days, sometimes even longer.
When the water finally arrives, Karen must use a well-honed strategy to optimize the irrigation of her lands.
First I run. Then I use my tools to optimize the flow as best as I can until it covers all of my land. I run.
Water sharing is a crucial issue. Traditional Atacama society is structured around water management. Assemblies decide on its distribution among inhabitants and manage the canals. Once a year, men gather to clean the canals that become clogged by silt from the Andes. Karen is an equitherapist. She uses her horses to provide therapy to children with autism. When there's no more water in the tap, she must take her horses to drink from the river. But even there, finding water is not a certainty. Today, Karen has no water, yet the pools of nearby hotels are full. The Salar and San Pedro attract tourists from all over the world. To offer them high-end services, despite Atacama's aridity, the hotels must have their own uptake system. The water is filtered by reverse osmosis and stored in retention basins. But the hotels draw from the same water table as the one that supplies Karen and the inhabitants of San Pedro. Even in the world's driest desert, sharing hydro resources is not always egalitarian in the name of economic growth. – 100 kilometers from San Pedro, the landscape offers a striking contrast. The area here is green. The inhabitants live on agriculture. Yet, as in San Pedro, it never rains. The situation has intrigued Chilean scientists since the 1960s. They discovered that this oasis of greenery existed thanks to a coastal mist. They too sought to use the wind and the mist. Pablo Oces is a climatologist. He claims that in the near future, we will have to colonize the deserts, driven by overpopulation and climate change. To prepare for this, Pablo has created an experimental base on the coastal range at the edge of the desert. He works on cloud catchers, a device invented in Chile to recover water from clouds and allow humans to live in arid environments.
We are expecting to see what's happened with the cloud, with the Camanchaca. Camanchaca is the native word to say fog. There are many elements related with the fog and cloud formation. One is the ocean, is the source of the humidity. That's one element. The second one is the sun radiation that allows the evaporation of the water from the ocean. And finally, we need wind. Three components to allow us to fill the Camanchaca. The unique source of water here is the Camanchaca, is the fog. So this water allows many plants to survive. And if there is vegetation, there are insects. So it allows an ecosystem to survive in the Atacama Desert. So take care when you walk, always.
On the dizzying slopes of the coastal range is the middle of the zone where the Camanchaca forms. The ancient inhabitants of Atacama would come to the foot of the flat stones to collect a precious liquid, water.
This flat wall stone that is covered by lichens right now was used by the native, by the ancient people from here, from the coast, to get water from fog. Drops falls down, they run down until the bottom, and they get the water. It's a real gift from nature that provides water for the natives and inspiration for the scientists. Give us the key.
Inspired by nature and ancestral techniques, Pablo has developed a model of cloud catcher that allows him to run his experimental station and foreshadow future desert cities.
The cloud is composed by thousands and millions of small drops. The drops hit the mesh, and one drop, another drop, creates a bigger drop. The triangle drives little drops from here to this point, and this other one also collaborates. So they are driven by the gravity, and they fall into this trough. It's a very, very, very basic system. That's the idea, to keep it simple, to allow any community in any place to develop their own fog collector.
The Camanchaca hasn't arrived yet. It's necessary to wait until mid-afternoon for the weather conditions to allow the appearance of fog. Around 5 p.m., the Camanchaca begins to form and drift in banks around the station. The suspended water droplets in the Camanchaca are too small to precipitate and form rain. And that's where the cloud catcher shows how effective it is. The first drops of water are forming on the mesh. A group of Chilean and American students from the Massachusetts Institute of Technology have come to visit Pablo's experimental station and his cloud catchers.
Aquí está. You see, drop by drop. In a day can be 350 liters in 24 hours.
The water captured by cloud catchers is fresh water, whereas a few hours ago it was seawater. Its journey through the clouds has desalinated it, but it must still be filtered and cleaned of atmospheric dust before consumption.
This system allows life and development in the driest areas, more than survive. If you want to survive, you can bring a bottle, but this one allowed the people live and develop activities in basic but good enough conditions.
Pablo is hoping that some of these students will carry on his work and contribute to the construction of his desert city. The Chilean students come from the Catholic University of the North at the forefront of architecture and design. The father of cloud catchers, Carlos Espinoza, is from this university. An atomic physicist, he discovered this device by chance in 1950 during a walk in the desert. In his backyard, he assembles one of these amazing diamond-shaped cloud catchers.
Blue, red, blue, red. That's fine. We stretched a horizontal cable between two small mountains. We left this in the mountains. When we returned the next day, the bottle was filled with water. We didn't know where the water came from. The water comes through it, and it's top quality water. It was very emotional. We began to cry. For us, it was something inconceivable.
Carlos donated his patent for cloud catchers to UNESCO so that anywhere in the world people can transform fog into drinking water. He then spent his whole life perfecting his structures, even creating volume models inspired by crystals that he calls macro diamonds. On the border between art and science, his cloud catchers have even been exhibited at the Palais de Tokyo in Paris. Is Carlos more artist than scientist?
No. It's another type of madness, because to be a good scientist is very absorbing. This was serendipity, as the Americans call it. It was chance. It was unintentional.
The serendipity Carlos is talking about refers to his chance discovery. He was able to observe an unexpected event and transform it into an innovation, just like Fleming did with penicillin. Chile offers scientists conditions conducive to serendipity by the extreme diversity of its climates and ecosystems. Here, you must be able to observe nature and learn from it. Observation and field studies recently allowed scientists to solve an old enigma. Why are the Chilean coasts so full of fish? From Patagonia to the Peruvian border, the area is one of the richest in the world and supports an economy based on fishing and aquaculture. Research has focused on the point of origin of this marine fauna, Patagonia. It is a region in southern Chile, sparsely populated with harsh conditions. The coasts are swept by constant rains, which turn into heavy snows inland. Patagonia is a maze of fjords and rivers, fed by the melting of impressive glaciers. In the heart of Patagonia lies a very isolated valley. This is where the source of Chilean marine wealth lies. A team of British scientists have set up their research base there. Getting there involves hours by boat, then on horseback. Here, there are no roads, no paths. The driver of the boat explains that the peaks around here don't even have names on the maps. Nature here is intact, a landscape of the origins of the world, the ideal spot for studying still virgin ecosystems. Don René provides logistics for the British scientists' camp. They've chosen a valley enclosed by the huge Stefan Glacier, 30 kilometers long. The same one that, through the millennia, has dug the whole length of this valley. The vegetation is short because this valley is a corridor scoured by glacial torrents that sweep everything before them. Don René is the only person to live in this valley, despite the danger.
The river changes a lot. It always changes every year. It comes down swollen from the melting ice. This happens especially in summer. All at once, the water level begins rising. The first time there was an avalanche, it overflowed like this, suddenly. A lot of water went down. It killed my horses, cows, sheep. And it has continued to happen. Last summer, 12 horses died. Now only these remain, this one and that one. Such is nature.
Glacial tidal waves are a major danger in the region. This is one of the research topics of Sarah Tingy and John Hawkins, two scientists from the University of Bristol. Sarah and John are taking their daily riverside samples from close to the Stefan Glacier Lagoon. It's their second research campaign in this Patagonian valley. They stay 3 weeks in their camp, established around a laboratory tent.
It's really important to try and keep things as clean as possible. So that means trying to minimize the amount of atmospheric dust that gets into the sample, into the chamber. In these filter stacks, we're filtering to get the particles out of the water. So it's the glacial flour that gives the milky color in the water. It's very difficult to find a location when you're on field work. You need a location that you think will answer the question you have, or that's what effect do the nutrients coming from glaciers have on ocean ecosystems. So you need a large glacial system that feeds an ocean system as well, and it's one glacier, one river, and one fjord system. So it's a relatively simple system to study.
The scientists are now leaving for the Glacier Lagoon. Sarah wants to take samples of glacial flour, a very special dust produced by glaciers. The Stefan Glacier is just one of the very many glaciers that cover the whole of southern Patagonia. They are located in interconnected valleys and make up what is called an ice field, some 350 kilometers long, stretching down the Andes. It is the third largest ice cap in the world after the Antarctic and Greenland. What are the conditions that allow this ice cap to exist at such low altitude?
So there's a few ingredients you need to build a glacier. You need precipitation that falls as snow, and you also need cold climatic conditions. So they receive a huge amount of precipitation and snowfall in the mountains here in Chile, and it's very cold in the mountains as well. And that helps build the glacier, and that's why there's so many glaciers here in the south of Chile.
In Patagonia, the glaciers are warm, almost at sea level. The Stefan Glacier is at an altitude of only 60 meters. That explains their blue color, characteristic of dense ice without any trapped air bubbles. As the summers are mild, the glaciers partly melt and then refreeze in winter. During the fluctuation between ice and water, air bubbles escape and the ice gets denser. But this melting creates glacial lakes which, when they empty suddenly, create destructive tidal waves.
We call these natural hazards GLOFs, which stands for glacial lake outburst floods. One such lake as this will reach a certain height and drain cataclysmically through the glacier and cause widespread flooding in downstream regions.
It was one such glacial tidal wave that swept away Don René's horses. Corridor-like valleys amplify the destructive effects of outburst floods.
The river we monitor rises around 8 meters in about 24 hours when these GLOF events occur, and that causes quite a lot of chaos for farmers downstream with their livestock. The precise timing of that is very, very difficult. At the University of Bristol, we're developing some sensors to put in some of these lakes, which will give us live feeds of lake height.
The outburst floods carry with them the glacial flour that Sarah is studying.
So glacial flour is formed by the glacier. As it's moving down, it crushes the rock really, really, really slowly up to this super, super fine, almost like glittery dust. I do something a little bit wacky with glacial flour. What I do is I use this glacial flour to fertilise crops as a soil fertility treatment with soils that are really low in nutrients. Yeah, I've grown wheat and soybeans so far. This is straight, fresh, crushed rock containing all the nutrients that plants would need. So hopefully it will make a good solution in the future.
Until now, glacial flour is perceived as an inconvenience because it blocks dams. But thanks to Sarah's research, the flour could be used as a natural fertilizer. This surprising discovery came from Sarah's intuition. Being a good scientist seems to involve stepping away from the norm.
I guess so, yeah. You have to be digging around in the cold, rainy mud. Yeah, certainly, yeah. I think so, yeah.
As the team heads down the river that escapes from the glacial lagoon, John wants to do an experiment to estimate the river's ability to carry suspended particles. He will use a dye called rhodomin whose traces he detects 2 kilometers downstream thanks to very sensitive sensors.
And glacial meltwater rivers are very turbulent. They're very active. I mean, they contain a lot of glacial flour, and you can see how turbulent and how quick-moving these rivers are.
The river from the glacier, carrying glacial flour, flows into Patagonia's complex river system. The river will flow into ever larger waterways and mix with the blue water from the lakes. The color of the water will change according to the concentration of glacial flour. Glaciers will thus contribute significantly to Patagonia's ecosystem, with the outburst floods as an occasional amplifier. Camilo Rada is a Chilean glaciologist. He has explored the huge ice field of Patagonia many times. He's preparing to cross it from east to west, a 3-week expedition in total autonomy. He will conduct field surveys to enhance his knowledge of the interconnections between glaciers and rivers.
We see in Patagonia with glaciers, with volcanoes that one year destroy everything, but 20 years later, you go back and this flourishing forest is the cycle of life. That's it. And all the nutrients that the glaciers cycle from these rocks back to the ocean have a large influence, like hundreds or thousands of kilometers into the oceans, like producing plankton and all the chain food to grow. So from the small microscopic algae to the big whales that thrive in these fjords and feed from them. Yeah.
Recent research by glaciologists and biologists is shedding light on the role of glaciers in ecosystems. But how can fine rock dust be the starting point of the ocean food chain? The answer lies in this huge bay, Tortel Bay. A very particular phenomenon takes place in Tortel Bay. This is where fresh water meets seawater that has flowed through the fjords from the Pacific. And from this meeting comes life, life studied by Rodrigo, marine biologist. At 26 meters, the net reaches a layer of salt water from the Pacific. The fresh water from the glaciers remains on the surface, and the nutrients descend gradually into the layer of seawater.
It has a lot of sediment, mainly in silicate. Silicon is an important nutrient for phytoplankton.
A microscope reveals a whole world living in the samples. These tiny monocellular algae are diatoms. They are born in Tortel Bay because they need silica to build their membrane. They were built by glacial flour. Thanks to the Humboldt current, they will be spread throughout the ocean, where they'll be swallowed by plankton, which in turn will feed fish and finally humans. Unfortunately for the inhabitants of Tortel, even though the Chilean oceanic food chain starts here, fishing in the bay isn't good. The glacial flour on the surface blocks the sunlight and prevents the growth of an ecosystem in the freshwater layer. The diatoms will benefit fish 100 kilometers downstream in the ocean. The inhabitants of Tortel had to turn to another resource to ensure their survival in this isolated region, constantly battered by the rains and subject to tsunamis. The inhabitants adapted. Rather than streets that would be swept away by tidal waves or earthquakes, they built 9 kilometers of cypress bridges. This wood, which grows in the surrounding forests, is perfect for the local conditions. It is virtually rot-proof, and its flexibility allows footbridges to withstand earthquakes. Despite the harsh climate and the isolation, the inhabitants of Tortel are attached to their village, nicknamed the Venice of Patagonia. Their village reflects the philosophy of the Chileans, in whom the spirit of the pioneers is always present. Knowing how to take advantage of the few available natural resources is essential to settling in extreme lands.